Thank you for joining me again. We are still under current electricity or electricity. We are still under this, and we'll be considering these two topics and these two questions rather. They are related to the calculation aspect of electric current, and here we're considering calculations that involve Ohm's law in circuits, where you have to check or calculate for the voltage, the current, the resistance, using the principle behind what? The arrangement of resistors either in series or in parallel. Now let's go. The first one, it says calculate the current in 3 ohms resistor shown in the diagram below. I think this is a WAEC question. I didn't write it here. It's a WAEC question. So you have this, you have this, have this. Okay. Sorry about that. Okay, we'll be fine. You have this. It says calculate first. Since you are calculating the current in 3 ohms resistor, don't forget what kind of arrangement is this? It is in parallel. The resistors are arranged in parallel form. Then what does that imply? It implies that different current flow through each resistor. The current flowing through 4 ohms is different from the current flowing through 3 ohms, different from the current flowing through 2 ohms. Do you get? But we have the same potential difference across each of these resistors. So what does that mean now? Let's calculate the current flowing through this. We already have the current in the whole circuit. Then which means we should look out for what? One, the combined resistance. Yes, which are the equivalent resistance. Then you look out for what again? The potential difference. Yeah. So the potential difference, so since it is the same thing for each of them, we're going to use it for 3. So that's all. So let's go. So we have equivalent resistance. Here we have R will be equals to 1 over 4 plus 1 over 3 plus 1 over 2. And finding the LCM should be 12. 4 in 12, 3 times 1, you have 3. Plus 3 in 12, 4 times 1, 4. Plus 2 in 12, 6 times 1, you have 6. And that becomes what? 4 plus 6, 10 plus that gives you 13 upon 12. So you have 13 upon 12. Having gotten this, this is our resistance, this in ohms. Don't forget. Then having gotten this, what do we look out for next? We'll go ahead to calculate the PD across the circuit. So what do we do? Let's calculate the PD now. Let me just make sure I wipe this. So what do we have? You go use the formula V equals to IR, that is the voltage equals to the product of your current and the resistance, is 13 upon 12. So we have coming from V equal to IR, the voltage will be 13 over 12 as the resistance times the current, which is of course is 13. But do you know we've not found our current, our resistance? So don't make that mistake, please. Don't make that mistake. We add 1 upon R to be equal to 13 upon 12. If you do your cross multiplication, you're going to be having 13R equals to 12. Dividing both sides by 13. What does this imply? This implies that your resistance will be 12 upon 13. Oh, this is the right value. What we got initially was what? Was still in the inverse form. So we have it to be 12 upon 13 everything ohms. So we have now V equal to IR, and that means voltage is the PD will be equal to the current, which is 13 times 12 upon 13. Let's cancel out this, so which means the voltage will be equal to 12 volts. That is a PD. You can trim this, so I have this. The potential difference is equal to 12 volts. Now, let's look at the current that flows through this 3 ohms resistor alone. So since V is equals to IR again, we are looking for the current, right? Our voltage is 12, so that will be 12 will be equal to what? The resistance is what? We don't know. So just make I subject perform. Okay, just go on. It will be I times the overall resistance we had was 12 upon 13. So what do we have now? That means I will be equal to, by the time you cross multiply, you have 12 times 13 divided by 12. This cancel out this, and that will be what? 13. You have 13 amperes. So your answer should be 13 amperes. So that's what we should have. You have 13 amperes, or you just have, okay, you have that. So current for 3 ohms. Did I use 3? Our voltage current times, okay, for 3 ohms rather, okay, sorry, we are calculating for 3 ohms, the current that flows through these 3 ohms. So here I'm supposed to use 3, yes. So what do we have? We have this 3, so that will be 12 divided by 3, and that will be 4. You have what? The 4 amperes. That will be the current that flows through this 3 ohms resistor. Question 2. Question 2 says, is also part of what we're doing. We have this. If a resistance is tripled, R is equal to 3R. So I'll call this R2, I'll call this R1. Then, and the PD across it is halved. That means V1 is equal to what? Half V2. It is halved. Or, yes, I can say R2 is equal to 3R1. Then, okay, let me put it that way so that there won't be confusion. Let me do it that way. It is, we have originally the resistance is tripled. R2 is now 3R1. Do you get this? R2 is now 3R1. It was R1 before, but R2 now is triple. The second, we have a new resistance. Do you get it? And it is equal to the 3 times what we have before. Then we have this. then and the PD across it is halved. So V2 is equal to half V1. And the ratio of the new current to the old is what? Normally V is equal to IR, and I will be equal to V over R. So since they are asking us the ratio of the new current, so I can say my I2 can be equal to what? V2 over, let me do it this way, I2 ratio I1 will be equal to V2 over R2, then ratio V1 over R1. Yes, good. So we are good to go this way. So what do we have? We have 3. This becomes the whole story will become what? Half over what? V2, which is half of V1, the half upon R2 over 3. Ratio, this one is just 1 over 1. So what does that mean? That implies that what? What does that imply? That implies that we have 3, 1 over 2 divided by 3 over 1. That becomes 1 over 2 times 1 over 3. Do you see that? So what do we have? That implies that we have 1 over 6 ratio 1 to 1. And that is also what? To invert it, you have 6 ratio 1. Do you see it? So the new to the old will be 6 ratio 1. So we have that sorted. Thank you for staying with me. See you some other time.